Hello, this is Mr. Heron. I wanted to talk to you about something I want to give you the big picture with statistics and critical thinking. That's what this course is all about. Math 11 is statistics, and the purpose of statistics is critical thinking. So I wanted to give you two examples to show you the importance of some of the ideas we're going to be learning this semester, this quick summer course in statistics, specifically how it helps us with critical thinking. Because especially in the modern age now, this has been called the information age, and that's well said because information is pouring into our lives daily. Through the internet especially and all kinds of online sources, information is being poured into us. And we need to be a critical, careful consumer of that information. How do you wisely take in, especially statistical, numerical information? That's, I think, the most valuable part of this course. Probably most of you won't actually do a lot of statistical studies yourself. You might, but you will all read statistical data very many times in life, on your job, in your home. You'll be flooded with statistical information. This course will help you be a more careful thinker, critical thinker about statistical information. So let's look at an example. Example 1 here. Boy Scouts becoming Christians. This is real data. Let's listen to this. So if we consider the 50 states of the United States, we find the states that have more Boy Scouts, 20 years later, tend to have more criminals. This is not made up. This is the truth. I'm telling you real, live data. This is not fake. I promise I'm telling you the whole truth. If you take the 50 states and you put them in order from number 1, number 2, number 3, the states that have the most Boy Scouts, I don't know what states those are, but whatever states have the most Boy Scouts, more Boy Scouts than other states, 20 years later, if we line up the states as far as how many criminals they have, we will tend, it won't be perfect, but we'll tend to see that the states that had more Boy Scouts 20 years later have more criminals. That's true. Again, I'm not faking that. That's the truth. Those are true numbers. And as they say, numbers don't lie. Well, that's kind of true. Numbers themselves don't lie, but people can use numbers to get you to believe a lie. And that's what we're seeing here. These are real numbers, and those numbers aren't false, but they are perhaps fooling us in what they mean. The question, of course, is, are the Boy Scouts cranking out criminals? Are they causing kids to grow up as criminals? Is that what we should conclude? Because it is true that states that have more Boy Scouts 20 years later have more criminals. And this isn't like a weird trick question. Oh, the trick is the criminals were from other states, but they just got locked up in this state because that's where they have the prison. No. It's nothing dumb like that. I'm not being dumb. It's nothing like that. I'm talking about actual people that grew up in the states that have more Boy Scouts. 20 years later, more of those people end up locked up in some prison as criminals than the states that had less Boy Scouts. They end up having less criminals 20 years later. That's true. That's a true fact. But does that mean that the Boy Scouts are cranking out criminals? Doesn't seem right. But what about the statistical numbers? Those are facts, right? Numbers don't lie. States that have more Boy Scouts, 20 years later, more criminals coming from them. What's up? Well, rather than leave you in suspense overnight or something, I will get to the point. There's something called a lurking variable. It'll make sense once I point it out to you. And that is the states with more Boy Scouts have higher population. population. Like California, right? We have the biggest population of all the states in the United States. And so we have the most Boy Scouts. And guess what? 20 years later, because we have the biggest population, we also have the most criminals. You see, the Boy Scouts are not causing people to become criminal. The lurking variable, lurking meaning hiding, the hiding variable, what's really causing both these things? What's really causing states to have more Boy Scouts and more criminals 20 years later is that they just have more population. They have more of everything. They have more honest people, more businessmen, more scientists, more street people, more criminals, more Boy Scouts, more Girl Scouts, more everything. They just have more population. You see, Boy Scouts are not causing people to become criminals, but population is the lurking variable. Population is causing both things to happen. The states to have more Boy Scouts, right? States with higher population have more everything, more Boy Scouts and more criminals, and states with lower population have less Boy Scouts and less criminals. So that's an example of how somebody could deceive you with statistics. When I first asked the question, it was hard to understand how we could not conclude that the Boy Scouts were cranking out criminals because states with more Boy Scouts 20 years later have more criminals. So do you see how we have to be careful there? Just because two things are connected doesn't mean one is necessarily causing the other. Just because Boy Scouts are connected to criminals, it doesn't mean Boy Scouts are causing people to become criminals. What was causing them both is population. So what we see there, let me write a sentence to help you be super clear on that. That, how you could summarize that is association, right? Two things being associated does not imply causation. Just because two things are associated, like Boy Scouts and criminals, more Boy Scouts and more criminals are tied together in various states, doesn't mean one thing's causing the other. Boy Scouts aren't causing criminals. There could be something else causing them both. So you got to be careful. You got to be a critical thinker when you hear statistical information. Happens all the time in the news and online, is people will cite that two things are connected, associated. More of one goes with more of the other. So therefore, that's causing, item A is causing item B. Not necessarily. Maybe, but not necessarily. Association does not necessarily imply causation. Now, it could be. How do you know if it really is? How do you know if the Boy Scouts are really cranking out criminals? Well, you would have to do a scientific study, which means you would have to have, and I can't get into it all right now, you'll see it in the lecture, some of these kind of things. You'd have to have like a control group. I don't know if you've ever heard about that. Let me make that. You'd have to have a control group and a treatment group, meaning you'd have to take like 1,000 people and 1,000 over here into two different groups, and the treatment would be they would go to Boy Scout training, whatever it's called, Boy Scout training when they're kids. You train them as Boy Scouts, and over here, no Boy Scouts. You don't send these 1,000 people to Boy Scout camp. And then 20 years later, you do a statistical study 20 years later, and then you see, and what you would find from just those 1,000, you would find that there's the same number of criminals. You're not getting more criminals. You're probably getting less among those that went to Boy Scouts. They're probably helping keep people from criminal behavior, certainly not causing it. So that would be that's called a controlled study. It's a scientific method. You see, you have to have a control group, a group that you don't give the treatment to, the treatment meaning the whatever you're wondering about, like Boy Scout training, if it's corrupt or not, That's a controlled study. That's how they test medicines, new medical treatments. That's how you really decide. That's the scientific method for really deciding if one thing is causing another. You've got to have one group that doesn't get the treatment, one group that does, and then measure it later, 20 years later or whatever, and you would find Boy Scouts are not cranking out criminals. Okay, so that's how you really get to the truth. That's the scientific method in statistics called a controlled study. Now, let's look at one more question. Example 2. Is milk causing cancer? If we divide the entire, this is the entire world, so the United States, entire world into 2 groups. Group number 1, people that have never had milk, even one time in their life. So I'm talking about never had it. Not just people that are maybe lactose intolerant, they don't like milk. The only way they would know they're lactose intolerant is if they had milk and had a bad reaction to it. No, I'm talking about group 1 is people that have never had milk even one time in their life. And now group 2. Group 2 is people that have had milk at least one time in their life. Even if they don't drink it regularly now, they at least had it one time in their life. Well, here again is some true information. I'm not lying. I'm not making this up. We find that those who have had milk at least once, group 2 that have had milk at least one time, group 2, tend to die of cancer at a much higher percentage rate. That's true. Again, I'm not making up false information. These are true numbers. This is real. This is true. Question is then, is milk causing cancer? So if you take, isn't this a controlled, this sounds like a controlled study like what I was just talking about, and it seems like it's proven that milk causes cancer. What's happened? Isn't this just like this study right here? I mean, right, we got this group that had milk at least one time, and this group over here, that this is the control group, right? This is the control group. They never had milk, right? Like over here, the control group, that no Boy Scout training, right? So isn't this the control group and this the treatment group? They got the milk. And I'm telling you, the treatment group dies of cancer at a much higher rate than the control group. In fact, almost nobody dies of cancer in the control group, the group that never had milk. That's true. Again, I'm not making this up. It isn't some dumb little thing. I don't know what kind of dumb explanation we might, tricky thing. It's not a dumb, tricky thing. It's nothing like that. This is real and this is true. So what's the conclusion? Should we clear the shelves? Milk's causing cancer. Get it out of here. No, again, it's not that. There's, again, a lurking variable. There's something else hidden causing them both. What is it? To give you a hint, let's think about group number 1 again for a second, the control group. People that have never had milk even one time in their lives. I imagine every one of you listening to this video have had milk at least once in your life. I bet you don't even know anybody that has never had milk even once in their life. I mean, who are these people in this control group? Never had milk even one time in their life? Think about this group. This is a strange group of people. Who is it? Like I said, I don't think you even know anybody that's never had milk even once in their life. Who are these people? Are you realizing it? These are severely impoverished people. Third world, sad. Malnutrition, right? This is malnutrition. They haven't even had milk once in a while. They live in some country where they don't even get food and water regularly, let alone milk. If they've never had milk, they're not getting proper nutrition. Okay, so what? What's that have to do with cancer? Well, what happens to people? So this group number 1 is a greatly malnourished group, usually. This is people that have never had milk once in their life. They're severely impoverished. They live in some place where they just don't even have basic nutrition, regular food, regular clean water. So what? What's that about cancer? What happens to people that are so terribly malnourished? They die, and they die young, don't they? They die when they're not old. They die. So group 1. So the lurking variable is age of death. You see, group number 1 doesn't get cancer because they die when they're 4 or 5 or an infant or a toddler. They don't even have a chance to grow up and get cancer, so to speak. Sounds weird to say that, but you know what I mean. Most people that die of cancer do so because they've lived older. Not always, of course. There's terrible exceptions, but usually. So group number 1, yeah, they don't die of cancer. They never had milk. They don't die of cancer because they don't even live past 5 years old usually. They die of malnutrition, being severely impoverished. They die of all kinds of other things. They don't even have a chance to die of cancer. The milk isn't causing cancer. People that drink milk are people that are in a more normal lifestyle and have normal nourishment that they need. And so they live to be a little older and have a chance of getting cancer. You see, the milk is not causing cancer. So, again, we see the lesson. Let me write it out again. Association does not necessarily imply causation. The milk is not causing cancer. Milk. No, so well then, wait a minute. What about my controlled study and everything? Let me tell you a little more about the control group. The control group and the treatment group. To be a scientifically controlled experiment. This is a controlled experiment. This milk experiment is not a controlled experiment, even though I made it look like it was. It is not. Why? The only difference, well, here, I'm not writing that very clearly. The two groups, the control group and the treatment group, must be the same in every way except control group gets no treatment, whatever the treatment is, Boy Scouts milk, whatever, and the treatment group gets the treatment, obviously. In other words, they have to be, the key here is, must be the same in every way except the treatment. And they're not, right? Look back at the milk example, right? They were not the same in every way. This group was terribly malnourished. So how would you actually test if milk is causing cancer? You'd have to have the control group that has the exact same nutrition except for milk. Plenty of food, plenty of water, clean water, medical care, everything. Same nutrition, no milk, and a treatment group. Same nutrition, and they're given milk. And then you could find out that milk does not, well, I would say the milk group, I would say die of cancer. Can't spell here. Die of cancer. Same percent. The same percent. You'd find there's no difference. That's the real controlled experiment. You have to have the same nutrition, same in every way. So that's what you got to do. The groups must be the same in every way. So the milk example can fool us. But see how that can fool us. Again, I'm trying to show you how statistical information, numbers never lie, but people can deceive us with numbers. See how things can appear to be something they're not. Again, the key is, just because two things are associated does not necessarily imply that one is causing the other. You got to be careful. To determine causation, you got to do a careful, controlled experiment where they get the same in every way, except no treatment for the control group, and the treatment group gets the treatment. That's how you can determine causation. So watch out when people point out the two things are associated and try to quickly, therefore, conclude causation. Association does not necessarily imply causation. That requires a careful, controlled study. That's how they determine if a new drug is really working, or a new medical procedure is really working, or a new business plan is really working. This is how business, engineering, medical science use statistics, and the news. This is how we determine what's really true, using statistical information. We need to be a critical thinker. That's what this course is about, is learning to think critically and make decisions involving statistical information. Well, again, welcome to Math 11, and I hope you come out the other end of this course thankful for it and having grown in your ability to think critically and spend the rest of your life as a wise consumer of statistical information.